So I'm going to spend the rest of the time to talk about Selector's ability to democratize access to data using our network LLM. And what do I mean by that? Like, what does data democratization mean, and why is it important for networks? Let's see if the clicker works. It works. Let's take a retail customer, and if you think of a retail customer, they have a very complicated, complex network. You have retail stores across the globe. Then that store is connected, and there are payment applications probably running at the cash register. One of the big challenges is the registers are not able to connect up to the payment application sitting in the cloud, and the network is always to blame. And now the networking infrastructure team comes in, and they have to figure out what's going on. Is it the Wi-Fi inside the store? Is it the LAN connection? There's probably an SD-WAN connection going out to the internet. And of course, you have the cloud provider. You have AWS, you have Azure. So now when things go wrong, people who are experts in each of these domains have access to that data. They understand what's going on. But any other person is not able to figure out where my problem is. This ability to be able to access any kind of data and understand across all of these different domains is data democratization. Like, you are no longer hostage to the experts or the vendors of that particular domain. Anybody is able to do that, and Selector provides that conversational interface so that this is possible. And what is that conversational interface? I want to first show you the interface. We'll do a brief preview of the demo, and John's going to walk you through some scenarios, and then we'll go into the technology. Right? So there are fundamentally two ways in which users see the insights. There is an alerting insight, like alerts get generated by Selector, and then there is a browse interface where you log into the system and you just interact with the system and ask questions. That's the conversational interface. So let's take the conversational interface. You're having issues at your retail sites. You just go and ask a simple question: are we having any uplink issues in the US? Once you do that, the entire topology pops in front of you, and you can continue your investigation from there on. And then you can keep asking questions, and we're going to show you how that works. And then, of course, the alerting layer, that when alerts are generated, it's not onesies and twosies, or like, one event and one alert. A consolidated alert shows up. That's shown over here, that somebody called Joe made a configuration change at a particular device, and that's caused a widespread outage. And that the different markets that are affected are listed in the alert, the different protocols, the different events that happen. They're close to about 50 events that this single alert encapsulates. So instead of seeing 50 alerts from this particular incident, you're able to see only one alert. What possible products got affected? Like, if this is a colo provider, one of their products is cloud on-ramp. Because of this change, their cloud on-ramp offering is probably at risk, or something's going on over there. All of that information is brought to you in their alert right away. And then once this alert shows up, it has different workflows. You can create an incident around it. You can create a PagerDuty incident or a ServiceNow incident and say that, this was what happened, and then teams downstream can then take care of that. So all of that stuff can happen from here. So I'll focus initially on the browse workflow, where how do you converse with the platform, and then we'll talk about the alerting later on. Let's do a very simple demo. So we have 3 sets of demos. The first set is where you have a backbone network that's providing connectivity to different aspects of the country. So there are data centers in the country, and you are providing connectivity through your backbone network. And you have an alert, or there's an ongoing issue going on that some sites are not able to connect to different sites. So when you come into the portal, it's all blank right now, and you start a conversation with the system. So John's going to enter the first conversation. Okay, show me, are there any latency issues going on anyway? As soon as you type in English, like, you would think, this is what you would think, like, are there any latency issues going on? The system does the query, and it shows you a general latency map. The details are not important, but you see a bunch of reds over there. That means there's certain areas. So, okay, let me see what my network topology is like. So that's the second question. Okay, what is my topology looking like? And once you enter that question, you get to see the entire topology right there. And then you go from there. And then as John is doing these queries, he's also saving the outputs for a troubleshooting session later on. The outputs that the query is producing are showing up as widgets, and John is saving them on the left-hand side and building a canvas from scratch. Like, you don't have to worry about the insights that, like the dashboards are already present. You're building the dashboard as you go along. And then now you know that because of the red is in a certain area in Denver, you can say, okay, now show me the topology around Denver, because you're now trying to get to the root cause and get to analysis of what's going on. As soon as you do that, you get a simpler view of the topology, which is just the connections around Denver, right? And so now you know Denver is connected to the rest of the country along these lines. And then you say, I know there are certain latency issues. I need to see what are the errors going on. And as soon as you say, what are my errors, you can say, show me the circuit errors around Denver. You type that question over here, and that right away shows you inside this whole thing, there is one circuit which is probably at risk and showing a lot of errors, and you get to the root cause right away. Right? Of course, if you had an alert, all of this information would have already been present, but this is a use case where you are sort of drilling down as a human and talking to the machine in English and able to get that there were some circuit errors inside Denver. And we'll go into more details about this workflow later on, but this is just a preview. The second example is from a customer who's built a multi-cloud environment, right? So they have built a backbone across the public clouds, and they provide connectivity to their tenants, which are applications running in public cloud. Similar issues happening over there. They know that there was an outage in US East by AWS, and they want to see, okay, were there any tenants that were affected by that, right? So they issued a query that, as John's going to show, who were my tenants that got affected by that outage? And suddenly you get to see there are a lot of tenants in US East, and there were like 3 of them were bad. So like, okay, now I need to know more about those tenants. So you issue your second question that I think it says, show me how many of those customers are bursting over their allocated quota. And as soon as you see that, you can see there are certain spikes over there. These are traditional line plots and all of that the system is presenting to you. But the manner in which this information is getting presented to you is very human-like. Right? And then you get to see what these tenants are doing, but you want to get a historical perspective. Like, I want to see, okay, in the past, how they've been doing that. And you say last 7, whatever, and you get to see a broader picture of what's going on. And as you can see over here, there are certain spikes over there. And of course, then you say, okay, now to remediate what's happening in the future. Are they likely to show this behavior going forward? Because as an organization, I might have to get ahead of it, maybe provision more bandwidth in that particular area so that my tenants have a better user experience. And they do that, and that's what's going to. And in this widget, you will see that I just said, show me the projected bandwidth over the next couple of months. And as soon as you do that, you get to see the projected bandwidth as well. So as you can see that it shows that this is what is happening in the past. In the future, this is mostly what's going to happen. So this is what they can do to see how the tenants are behaving in the future. And the last example is we want to show is around the retail, where the retail customer has a bunch of stores, and these stores are connecting up to the cloud. And then you say that is my stores in Atlanta having some issues with the cloud? So you issue those queries again, and then you keep going, and eventually you get to see, yes, the certain stores in Atlanta, they're having connectivity issues. And then you say, okay, most likely there are certain providers, internet providers in that area that could be causing issues. So you want to know what are my providers in Atlanta. So you say, show me my providers, because as in English, that's what you're going to ask. What are my providers in Atlanta? You get a list of those providers, and those providers are. I think I'm going faster than the demo.
You're fine.
So you get to see who my providers are. It says your providers in that particular area are AT&T, Verizon, or Comcast. And then the next obvious thing you want to say is, are providers having issues in a particular area? And then you start doing that, and then you get to see all the issues. Like, for example, there were a lot of providers across, like this Comcast, there's CenturyLink, and there are a lot of providers over there. Eventually, you want to see, okay, Verizon is probably the issue. How do I go about tracking Verizon? I think I spoke faster again. So I guess you get a sense of how English queries, how English sentences get translated into underlying queries in the system, and that's the user experience like. Now I want to walk into the technology stack, how this is possible, right? Because we all want that from conversational interfaces. We all want that from chatbots. But why is it hard to do it in the context of networking data and infrastructure that we all manage? What is the hard part about it?
As you dive in here, this is Chris Grundeman, and you may be exactly going to cover this next, but I'm really curious about the model behind this. If this is something that you've kind of actually built and trained your own LLM, or if this is based on something else that's just got some like rags.
I'm going to be talking exactly about all of those things. Thank you, Chris.
Yeah, if I could jump in too, sorry, this is Remington. I'm really curious because I'm watching a lot of stuff happen in terms of like a CMDB and service mapping, service catalog offerings, like the interaction I'm watching happen here, like in the back of my mind, I'm sort of putting those pieces together. So for a customer that doesn't potentially have that, well done or well updated, is that part of what your managed service is building essentially for the customer? Or can you maybe clarify like how that part works? Or maybe I don't even have a CMDB, right?
So I'll talk about that later as well. Even if it might not be as part of a formal CMDB, that information is always available. They might have spreadsheets. They might have a Google Drive sitting somewhere where the metadata is available. So our system, so part of the managed services, they give us those connections, and our system will poll into those endpoints and build a table or a CMDB in our system. So if the customer doesn't have a formal CMDB, we do build it for our operations, because the CMDB is the single most important thing that gives you business context to these queries. Because the raw data most of the time does not tell you whether it's Verizon or AT&T. It'll just have some cryptic IP or some ID. That ID to Verizon mapping is sitting somewhere else. And we build that to be able to give that kind of user experience.
Okay, gotcha. And is there a hook, if I do have a really well curated CMDB, that allows me to basically keep it in sync with your efforts? So like as I'm onboarding hardware and adding inventory, I put it in my system and it's going to then push up.
Yeah, we have sophisticated customers, like a lot of customers who use Netbox as a CMDB on their side. As they onboard devices, they onboard circuits or service provider, whatever they're doing. So we have a first-class integration with Netbox. So they give us credentials to access that Netbox. We periodically scrape that, and then we transfer that information on our side. For other customers who want Netbox as a CMDB, we do offer that as well. Because maybe for some reason you have not operationalized Netbox, or you haven't done a certain things. We do provide Netbox as a service as well.
Cool, thank you.
Yeah.
Hi, this is Micheline Murphy. Could you just go into, you don't need to do it too deeply, but I'm really just kind of curious, for customers that their CMDB is in sad shape or they don't have one, or, for whatever reason, could you just talk to us a little bit about the discovery process? I mean,
Sure.
you have like something that just gets into their network and crawls it and builds it that way.
Let me if you hold on to the question. I'm probably going to get to that as I describe the stack, and I will make sure I answer that in that context.
I'll hold then.
Yeah, thank you. So
stuck again.
Yeah, so with last few years have been very revolutionary when it comes to conversation, LLMs, and all of that. And there is a natural tendency to to assume that we have ChatGPT, we have Google Gemini. Can I take my infrastructure data and then just connect up to ChatGPT and stuff like that and get a conversational interface? Fair question. And the issue with that is there's a big chasm between where infrastructure sits and these services. The first thing is they're all sitting in public cloud. They are public services that these companies offer, and your data is sitting in on premises or in certain infrastructure. How do you get your data from point A to these services? That's number one. Even if you magically got it over there, the models and the models that these services have been trained on are really largely English. They understand how's the weather like, why is Spain farther away than from the US than the UK, whatever, right? They understand all of that English language, but they do not understand optics levels on a Cisco or an Arista line card. They do not do that. People haven't taught these models what these things mean. SNMP data, syslogs from vendors. So not only is the distance a problem, even the semantics of that information that sits in these systems is incomplete, and that problem needs to be solved. And to do that, you need to bridge the gap. You need to bridge the gap. You need to build a layer of software that connects. So first of all, you cannot use large language models sitting in these public clouds. You have to build a large language model, and that's what I'm going to talk about more later on, that how did Selector build this LLM? So you have to first get an LLM, deploy an LLM closer on premises. Once you do that, then you have to connect up your infrastructure to the LLM. Now that connection is a very involved technical stack, and that's what our company is. You need to write that software to be able to collect the data. So, collection of the data itself is a big problem. You need to be able to know what devices that you want to go to, and that's the crawling aspect. There are mechanisms where you can say that discover all my devices in this subnet or this particular region, and you go out and figure out what those devices are, do the last mile connection, start SNMP polling them or GNMI polling them. You have to do a lot of that. And then this collection has to be diverse. It has to span across the globe. So you need to deploy a fleet of collectors in the US, in Asia, wherever your infrastructure is, because these collectors have to be close to the infrastructure. Once they collect the data, they have to present the data to a uniform layer upstairs. And there is no universal data format. An SNMP format looks very different from something else. So you need to build a layer which is able to understand any schema and convert to some sort of a normalized schema. And that's the technology that we build. We have a data compiler, which we call a data hypervisor, just like compute hypervisors abstracted the details of disk, compute, and storage from applications. We've built a data hypervisor that hides the variety of formats of the underlying data and present it in a uniform way up to the storage layers. Then you have to store this data. The storage is also very different. The storage for logs is very different, and the storage for metrics is very different from the storage of events. You have to roll out a storage layer. And once you have storage, you have to be able to query it in some sort of a uniform way. And then the query interface has to then connect up to the LLM so that it can start thinking about user English and all of that. Right? So you have to build that stack.
I have a question. Michael Winston, Fiserv. The collection means I get a bunch of data from existing systems. You mentioned Netbox, which means I'm going to assume you also support Notobot and other places where I can pull data in, maybe ServiceNow or Forward Networks or something to that extent. And then the data hypervisor does the ETL.
Yes.
Before it gets feed it into the data store. So the data hypervisor is doing the normalization. Do we program the logic in the data hypervisor to say that this field here maps to this field there? that field, so the transformation takes place?
You don't program it, you configure it. There's a difference. The program is you have to write code, but here sometimes the schema can be discovered. The system discovers what the schema should be, but then as a human or somebody who operates the system can say, no, I don't like your discovery. I want you to do the schema mapping along those lines. So yes, that's the intent that you configure in the data hypervisor, and that performs the transformation part of ETL. Did I answer your question?
Yep, you did.
Okay.
I'm really interested in learning more about that collection and data hypervisor, because those two left boxes are usually the hardest part of feeding any system, is how you get the data in and not having to set up, yet another platform as a collector. So it's got to collect the data all on its own. Doing ETL makes it much more malleable.
And that's, again, the aspect that Deba brought out initially. Why have we had success in deployments? Because if you do not have a data compiler, you will get stuck at this layer. If you start building a connector per customer, it takes a long development cycle. You will not be able to ingest data. If you cannot ingest data, your rest of you might have a very sophisticated query, you might have a sophisticated LLM. If you cannot ingest data, all of that becomes not useful. Right? So having that data compiler was a very important step in our innovation, because coming from Juniper and networking vendors, we knew that there's no single format that's going to be applicable to all infrastructure, and we need to just embrace the diversity and not run away from it.